So, dear students, in this video we are going to discuss about chain rule. Chain rule is used to find the derivative of functions of functions. Okay, though this is not so important for your math syllabus in class 11, but it may be helpful in your physics. That's why I am discussing it here. And our second year differentiation will be started from this chain rule. Okay, so what is chain rule and what are functions of functions? As you all know, sin x, e to the power x, log x, x square, all these are functions. Okay. Now, what is functions of functions? Suppose if I write log of sin x. Okay. Of course, this is mod sin x. Okay, log of sin x. Then it's a function of function, because log is a function which is applied on another function sin. So this is a function of function. Let me write something else also. Y equal to e to the power sin x. E to the power x is a function, and in place of x we have written sin x. So sin is another function which is come in place of x. So this is a function of function. Alright. Another one, say log of tan x square. Okay, this is also function of functions. Here there are three functions. One is log function, one is tan function, one is x square function. So such type, we can find the derivatives of such type of functions by using chain rule. What is chain rule? Now we are going to discuss about chain rule. Suppose y is a function of u, where u is a function of another variable v, and v is a function of another variable x. Okay, so how is the relation? Y is related to u is related to v, and v is related to x. So ultimately y is related to x, though through a chain of relations. So ultimately y is a function of functions. Y is a function of u, which is again a function of v, and v is a function of x. So y is a function of function. So how to differentiate y with respect to x? To differentiate with respect y with respect to x, what do we do? dy, y is a function of u, so first we will differentiate y with respect to u. Then u is a function of v, we will differentiate u with respect to v. Then v is a function of x, we will differentiate v with respect to x. And all these derivatives will be multiplied, and that will give us dy dx. This is chain rule. Okay. Suppose we are to differentiate this function. Y is equal to e to the power sin x. So, while differentiating, how will you think? Dy by dx. Okay. So I will think it as e to the power x. Alright? I will think this as x. So derivative of e to the power x is e to the power x. Now I will see what is x here. Here x is sin x. No direct x, but sin x. This is not x, but a function of x is taken as x. So we will multiply the derivative of that function, which is taken as x here. We will multiply the derivative of that function, which is taken as x in the functional form. This function is e to the power x. We have treated it as e to the power x. And in place of x, that is sin x. So it's a function. Okay. So we will differentiate this one by treating as e to the power x. Derivative of e to the power x is e to the power x. Now we will see what is in place of x. In place of x, there is sin x. It's not direct x, but a function of x. In that case, we will multiply that function of x. Now, e to the power sin x is okay. It is outside the derivative side operator. Now dtx of sin x is cos x. Now what is x here? Here x is x. So the chain will stop here. So derivative of e to the power sin x with respect to x is e to the power sin x into cos x. Let me take one more example. say this one, log of tan of x square, log of tan of x square. Okay, so what is this function? We will treat as log x. Okay, we will treat this whole thing as x. Okay, so dy dx will be, this is what? This is log x, and derivative of log x is what? 1 by x. 1 by x. Alright, now what is x here? X is tan x square. In place of x there is tan x square, which is not x but a function of x. So its derivative will be multiplied here, d dx of tan x square. Okay, now we will differentiate this one, is equal to 1 by tan x square. Now to differentiate this part, we will treat this as tan x. Okay, so what is this function? This is tan x function, and derivative of tan x is sec x square. What is in place of x here? In place of x there is x square, which is not direct x but a function of x. So its derivative will be multiplied here. Okay, so its derivative will be multiplied here. This is equal to 1 by tan x square into sec x square. Now what is the derivative of x square? Derivative of x square is twice x. Now what is in place of x here? X square. The function is x square. So in place of x there is x. So the chain stops here. Whenever we get x in place of x, the chain stops there. Okay? Okay. Let me take one more example. Say y is equal to sine of 2x square plus 5. Okay. Therefore, dy dx is equal to, what is the function? The function is sine x, and in place of x there is 2x square plus 5. Okay. Derivative of sine x is cos x. Cos x. This is x here. So in place of x there is no direct x but a function of x. So its derivative should be multiplied d dx of 2x square plus 5. Okay. This is equal to, this is outside the differential operator. Okay. Now the derivative of this. Okay. So 2x square, derivative of 2x square is 2 into 2 into x, that is 4x, and derivative of 5 is 0. Now what is in place of x here? In place of x there is x. So the chain stops here. So the derivative is 4x cos of 2x square plus 5. Okay. So I have just given you an idea of the chain rule, which will be helpful for your physics. Okay. So at this point, temporarily we will leave calculus here. And there is one more thing in your calculus syllabus which is related to gradient. Okay. So first we will do coordinate. We will start coordinate, and after learning what is gradient and some properties of gradient, we will again come back to calculus and we will continue that gradient, that part of calculus which we have left here. Okay. So let us start coordinate geometry. After learning gradient, we will again come back to calculus to finish our last part of the calculus. So today we will start coordinate geometry. Coordinate geometry. So what is coordinate geometry? Coordinate geometry is the mathematics of position. Coordinate is the mathematics of position. To study something related to position, we use coordinate geometry. So all of you have learned some or more about coordinate geometry in your class 10. Okay. In your general math syllabus, you have got some idea about coordinate geometry. In your advanced syllabus, you have learned a lot about coordinate geometry. Okay. So I will start considering the general mathematics. Okay. In general mathematics, you know what we do. To find the position of a point on a plane, we need two perpendicular axes which are known as x-axis and y-axis. Okay, and their intersecting point is known as the origin, and that is taken as O. Okay. The right part from origin of x-axis is known as positive x-axis, and the left part from origin of x-axis is known as the negative y-axis. Upper part of y-axis from the origin is known as positive y-axis, and the lower half is known as the negative y-axis. So these two axes divide the whole plane into four equal parts, which are called quadrants. So this is our first quadrant, this is second quadrant, this is third quadrant, this is fourth quadrant. In first quadrant, you see, first quadrant is bounded by positive x-axis and positive y-axis. So we denote by plus plus. Here both x and y are positive. Second quadrant is bounded by negative x-axis and positive y-axis. So we denote by minus plus. Third quadrant is bounded by negative x and negative y. So we denote it by minus minus. Means here both x and y are negative. Fourth quadrant is bounded by positive x and negative y. So it is plus minus. Here x is positive but y is negative. Alright. Now how do we find the position of a point on a plane? Suppose this is a point on the plane. Okay. Then to find the position, we draw a perpendicular to any one of the axes. Generally we draw perpendicular on x-axis. Okay. Then perpendicular distance of x-axis from that point is its y-coordinate. Point to x-axis distance is the y-coordinate, and from point perpendicular distance of y-axis is the x-coordinate. So this length is your x-coordinate, and this length, PL length, is your y-coordinate. OL is x and PL is y. And then we say that the coordinate of the point is xy. So what we have learned? We have learned that what is x-coordinate? X-coordinate is the perpendicular distance of the point from y-axis. And what is y-coordinate? Y-coordinate is the perpendicular distance of the point from x-axis. So distance from x-axis is y-coordinate, distance from y-axis is x-coordinate. Okay? That's what we have learned in your class 10 syllabus. Okay? Then we have also learned distance formula. Okay? Suppose there are 2 points on a plane. Coordinate of one point is x1, y1, and there is another point whose coordinate is x2, y2. Then the distance between these 2 points, this distance, say d. The formula to find this distance d is equal to under root. D is what? D is the distance PQ. That is the distance between the points P and Q. Is x2 minus x1 whole square plus y2 minus y1 whole square. So what is the distance formula? Difference of the x coordinate whole square plus difference of the y coordinate whole square whole root. Okay? Difference of x coordinates whole square plus difference of y coordinate whole square whole root. This is the distance formula. Okay? All of you know this. You have learned it in your class 10 syllabus. Now, in the distance formula, there are 5 parameters. One is d, one is x1, one is x2, one is y1, one is y2. So 5 parameters are there. Okay. So out of these 5 parameters, if any 4 are given, then we can find the 5th. Okay. Suppose x1, x2, y1, y2 are given, then we can find d1, d. If suppose d, x2, y2, y1 are given, then we can find x1. In this way, out of the 5, if any 4 are given, we can find the 5th. Okay. So there will be some problems related to this. Suppose we are given, and let us take an example. What is the distance between the points P2 minus 3 and minus 1 minus 5. Okay, Q minus 1 minus 5. So we have to find the distance between these two points. Directly you write the formula. D is equal to under root x2 minus x1 whole square plus y2 minus y1 whole square. This is equal to under root minus 1 minus 2 whole square plus minus 5 minus minus plus 3 whole square. This is equal to under root 9 plus minus 2 whole square is 4 is equal to root 30 units. Okay, so we found the distance. Here x1, x2, y1, y2 are given and d is missing. We found d. In the same way, any one of the parameter may be missing and we can find that parameter. Okay. Suppose the same question. Distance between the points between the points 2 minus 3 and a minus 5 is root 13 units. Find a. Okay. So here you see x1, x2, y2 and d are given. We have to find y1. So out of the 5, 4 is given and we have to find the fifth. Okay. So how will solve this? We know d is equal to under root x2 minus x1 whole square plus y2 minus y1 whole square. Here d is given to be root 13 under root x2. What is x2? x2 is a and x1 is 2. So a minus 2 whole square. Y2 plus y2 is minus 5 and y1 is minus 3. So minus minus it will be plus 3 whole square. Okay. Squaring both sides we get 13 is equal to a minus 2 whole square plus 4. Do I correct? Yeah. So this implies a minus 2 whole square is equal to 13 minus 4 implies a minus 2 whole square is equal to 9. This implies a minus 2 is equal to plus minus 3. This implies a is equal to minus 2 plus minus 3. Therefore, a is equal to, so what is it? If we take 3 as positive, then it will be 1. Oh, no. 2 plus minus 3. Sorry. 2 plus minus 3. If we take 3 as positive, then a is 5. And if we take here minus sign, then a will be minus 1. So there are two values of a, either 5 or minus 1. Okay. In this way, out of the 5 parameters, if any one is missing, we can find that. Okay. Now, there are some other applications also. On the basis of lengths of the sides, you know, there are 4 types of triangles: equilateral triangle, isosceles triangle, scalene triangle, and right angle triangle, though definition is based on angle, but by using hypotenuse we can relate it to sides. So by using Pythagoras theorem you can relate it to sides. So this is also side based. Okay. So a right angle triangle in this way is also side based. By using Pythagoras theorem we can relate it to a right angle triangle to sides. So on the basis of side, length of sides, there are 4 triangles: equilateral triangle, isosceles triangle, scalene triangle, and right angle triangle. What is an equilateral triangle? A triangle whose 3 sides are equal is called an equilateral triangle. What is an isosceles triangle? A triangle whose 2 sides are equal is called an isosceles triangle. What is a scalene triangle? A triangle whose 3 sides are unequal is called a scalene triangle. And what is a right angle triangle? A triangle whose one angle is 90 degrees is called a right angle triangle. And for this triangle there are 3 sides. You all know that base, perpendicular, and hypotenuse follows the Pythagoras formula, which is given as hypotenuse square is equal to base square plus perpendicular square. Okay, so this is Pythagoras theorem. So if a triangle satisfies, the 3 sides of a triangle satisfies this property, then we can say that it is a right angle triangle. So if among the 3 sides of a triangle, if square of one side is equal to the sum of the squares of the other 2 sides, then the triangle is a right angle triangle. So using these properties, we can prove that a triangle is equilateral, scalene, or isosceles, or right angled. Okay. So let us do some of problems of this type. So this is our first question related to that triangle. Show that the triangle having vertices a0 minus a0 0 root 3a is equilateral. First of all, let us name the vertices. Solution. Let a0. In some of the questions you may found the points with their names, the vertices with their names. If the name is given, no problem. If name is not named, you have to name the vertices. And C0 root 3a be the vertices. Be the vertices. Therefore, AB is equal to under root. So this is AB, this is x1, y1, this is x2, y2. So x2 minus x1 whole square plus y2 minus y1 whole square. This is equal to root over 4s square is equal to twice. Negative sign is not taken because length cannot be negative. Similarly, BC is equal to under root B and C. x1, x2, y1, y2. So x2 minus x1. 0 plus a whole square plus root 3a minus 0 whole square. This is equal to s square plus 3a square. That is again 4s square is equal to twice a. Okay. Then we will find CA. Another side is CA. C and A. C, A. So this is 1, this is 2. x1, y1, x2, y2. Okay, x1, y1, x2, y2, because we have taken it as CA. So x2 minus x1 whole square plus y2 minus y1 whole square. Again, s square plus 3s square, that is 4s square is equal to twice a. So what you see, AB is equal to twice a, BC is equal to twice a, and CA is equal to twice a. That we write therefore AB is equal to BC is equal to CA. So all the sides of the triangle are equal, hence the triangle is an equilateral triangle. Therefore, triangle ABC is an equilateral triangle. Equilateral triangle, which we know as Shomabahu Tribuj in Bengali. Okay, so ABC is an equilateral triangle. Similarly, if you are asked by giving some vertices that show that these vertices form an isosceles triangle, that means you have to show that two sides are equal. Isosceles triangle means Samaddibahu Tribuj. If by giving three vertices, you are asked to show that these three vertices form a scalene triangle. Scalene triangle means Vishambahu Tribuj. That means you are to show that the sides, all the three sides are unequal. If by giving three vertices, let me do one example. Show that the triangle having vertices having vertices A -1 1, B 2 -2 and C 8 4 is a right angled triangle. Right angled triangle means Samapuni Tribuj. In Bengali you call it Samapuni Tribuj for the Bengali medium students. Show that this form a right angled triangle. That means we have to show that this triangle follows the Pythagoras theorem. For that we have to find the length of three sides of the triangle. AB is equal to x2 minus x1. So 2 minus minus plus 1 whole square. Plus y2 minus y1, that is -2 minus 1 whole square. This is equal to 2 plus 1, 3 square, that is 9 plus 9. This is equal to root 18. Okay. Then BC, x1, x2, y1, y2. So 8 minus 2, x2 minus x1 whole square. Plus y2 minus y1, 4 minus minus plus 2 whole square. So 8 minus 2 is 6, 6 square is 36, plus 4 plus 2 is 6, again 36, equal to root 17. Then we will find CA, x1, y1, x2, y2. So CA is 8 minus minus plus 1 whole square plus 4 minus 1, 4 minus 1 whole square. So 8 plus 1, that is 9 square, that is 81, plus 3 square, that is 9, is equal to root 90. Now, you see here, AB square plus BC square will be 18 plus 72 is equal to 90, which is CS square. Now, AB square plus BC square is equal to AB square is 18, BC square is 72, is equal to 90, which is CS square. So, square of sum of the squares of two sides of the triangle is equal to the square of the third side. So, it's a right angled triangle. Okay, by Pythagoras theorem, it's a right angled triangle. So, we will write here, therefore, triangle ABC is a right angled triangle. Is a right angled triangle. Okay, so in this way we can show that a triangle is isosceles, a triangle is scalene, a triangle is right angled, a triangle is equilateral. Now let us discuss about quadrilateral. So, quadrilateral means chaturbuj. There are different types of quadrilateral, as you know. Parallelogram, then rectangle, then rhombus, then square. Okay. We will discuss about this. So what is a parallelogram? Parallelogram means samantali. So parallelogram is a quadrilateral whose opposite sides are equal. AB is equal to CD, BC is equal to AD. If ABCD be the quadrilateral and opposite sides are equal and the diagonals are unequal. AC not equal to BD. Okay. So in that case, the quadrilateral ABCD will be called as a parallelogram. Okay. Opposite sides are equal and diagonals are unequal. So what is a rectangle? In rectangle, opposite sides are equal. AB is equal to CD, BC is equal to AD, and the diagonals are also equal. AC is equal to BD. Then we will say that the quadrilateral is a rectangle. Rhombus, four sides are equal. AB is equal to CD is equal to BC is equal to AD, and the diagonals are unequal. AC not equal to BD. Then we say that the quadrilateral is a rhombus. Four sides are equal, diagonals are unequal. Then we say that the quadrilateral is a rhombus. If in quadrilateral ABCD, AB is equal to CD is equal to BC is equal to AD, and SC is equal to BD, then we say that the quadrilateral ABCD is a square. That means the four sides are equal and the diagonals are also equal. Then we say that the quadrilateral is a square. So if the four vertices of a quadrilateral are given, by using these properties we can show that it's a parallelogram, it's a rectangle, it's a rhombus, it's a square. Okay, according to which property it satisfies. So let us solve an example like that. So an example here, this is the question. Show that the points A13, B34, C 4 minus 3 and D 6 minus 2 taken in order are the vertices of a rectangle. Okay. So first we will find the lengths of all sides. So we'll start with AB. Here AB is equal to under root A x1 x2 y1 y2. So x1 minus x2 plus y1 minus y2, okay, whole square. This is equal to 4 plus 1 is equal to root 5. Then we will find BC x2 minus x1 plus y2 minus y1, that is minus 3 minus 4. Okay. This is equal to 1 plus 49 is equal to root 50. Then we find CD C, D. X1, X2, Y1, Y2. So X2 minus X1, that is 6 minus 4 whole square plus Y2 minus Y1 minus 2 plus 3 whole square. This is equal to 4 plus 1 is equal to root 5. Alright? Then we will find dA. So these are x1, x2, these are y1, x1, y1, x2, y2. So x2 minus x1, that is 1 minus 6 whole square plus 3 minus plus 2 whole square. This is equal to 25 plus 25, that is equal to root 50. So we have found lengths of all sides. Now we will find the lengths of the diagonals. What are the diagonals? AC. Okay, do you get it? ABCD is a rectangle, any quadrilateral ABCD. So the sides are AB, BC, CD and DA. And the diagonals are AC, AC and BD. Okay, so AC, A and C. So these are x1, y1, x2, y2. So 4 minus 1 whole square minus 3 minus plus minus 3 minus 3 whole square. 4 minus 1, that is 3, 9 plus 6 square, that is 36 is equal to under root 45. Alright? Then BD. BD. Okay? So B and D. X1, Y1, X2, Y2. So X2 minus X1, that is 6 minus 3 whole square plus Y2 minus Y1 minus 2 minus 4 whole square. 6 minus 3, that is 3 is equal to 3 square is 9 plus 6 square is 36 is equal to root 45. So thus we see that. So what do we see? We see that AB is equal to CD, BC is equal to AD and AC is equal to B. That means opposite sides are equal and the diagonals are equal. Therefore, ABCD is a rectangle. Okay. In this way, you can show that a quadrilateral is a parallelogram. Parallelogram, if AC not equal to BD, AB is equal to CD, BC is equal to AD, AC not equal to BD, then you can conclude that the quadrilateral ABCD is a parallelogram. Similarly, rhombus, AB is equal to BC is equal to CD is equal to DA and AC not equal to BD, then it's a rhombus. It's the same way. You will find the lengths of the four sides and the diagonals, then you will show that AB is equal to BC is equal to CD is equal to DA and AC not equal to BD, then the quadrilateral ABCD is a rhombus. Similarly, to show the quadrilateral ABCD is a square, we have to show that AB is equal to BC is equal to CD is equal to DA. Just like this, you find AB, you find BC, you find CD, DA, AC, BD. Okay, AB is equal to BC is equal to CD is equal to DA and AC is equal to BD. Then we will say that, we will conclude that the quadrilateral ABCD is a square. So I hope you can do all such types of problems. Now, let us move to the next topic. So our next formula is section formulae. So section formulae, there are two types of section formulae. One is for internal division and another is external division. External division. So first we will learn about internal division. Suppose P and Q are 2 points on a plane and they are joined, that is the line PQ is divided by a point R in a ratio m:n. By a point R internally, that is internally means the point R divides the line PQ in between P and Q. Then we say that the division is internal. When R lies between P and Q, it is known as internal division. Okay. So P and Q are 2 points whose coordinates are given, and a point R divides the join of PQ in a ratio m:n. Then we can find the coordinates of this dividing point R by using the section formula, internal division, and which is coordinates of R will be first ratio, second coordinate. First ratio, second coordinate. So first ratio is m:n. So the first ratio is m, second coordinate is x2. First ratio, second coordinate plus second ratio, first coordinate divided by sum of the ratios. Similarly for y, the same formula, the y coordinate will be taken, first ratio, second coordinate, that means the second y coordinate. For y, second coordinate, in case of x coordinate, we will take the second x coordinate. For first coordinate, in case of x, we take the first x coordinate. So first ratio, second coordinate plus second ratio, first coordinate divided by sum of the ratios. So this is the internal division formula. And for external division, in external division what happens? Suppose Px1, y1 and Qx2, y2 are any 2 points on a given plane. Then the join of PQ is a line. Line means what? Infinite signal. It's extended on both sides. That is the definition of line. Okay? This is a line segment. When I say line, it means it extended on both sides. Okay. So PQ is extended on both sides. The line PQ is extended on both sides. If a point R divides the line PQ, where R lies outside the line segment PQ, outside PQ, it may be on this side or on that side, then the division is known as external division. And in this case also, PR divides PQ in a ratio m:n, means if the length PR is m and QR is n, then we said that the ratio is m:n. So R divides PQ externally in a ratio m:n. In that case, by external division formula, we can find the coordinates of R. And what is the external division formula? Almost same, first ratio, second coordinate. In place of minus, there is plus, there is minus. First ratio, second coordinate minus second ratio, first coordinate divided by difference of the ratios. Similarly, first ratio, second coordinate minus second ratio, first coordinate divided by difference of the ratios. This is the external division formula. So, internal division, first ratio, second coordinate plus second ratio, first coordinate divided by sum of the ratios. For x, x coordinates will be taken, and for y, y coordinates will be taken. Formula is the same. For external division, first ratio, second coordinate minus second ratio, first coordinate divided by difference of the ratios. X coordinate, for x, x coordinates will be taken, and for y, y coordinates will be taken. Okay. So very easy formula. Alright. Now let us apply this one. Let us take a question from the book. Find the coordinates of the point which divides the line segment joining the points line segment joining the points P4 minus 7, sorry, P minus 4 7 and Q 5 minus 9 in a ratio in a ratio 3:2. 3:2. Question A, internally, and B, externally. Okay. So we are to find the dividing point when the division is internal and when the division is external. So let R be the point. R be the point which divides PQ, number A, internal. So internal division is internal, that means we have to use the internal division formula. Therefore R is equal to, so remember what is the formula? First ratio second coordinate plus second ratio first coordinate. What is the first ratio here? 3. Second ratio 2. So first ratio, this is x coordinate, so we will mean coordinate means the x coordinate here. For x, coordinate means the x coordinate. First ratio, this is the second x coordinate, second coordinate plus second ratio first coordinate. 2 into minus 4 divided by sum of the ratios, 3 plus 2. For y coordinate, first coordinate means first y coordinate, second coordinate means second y coordinate. Again, first ratio second coordinate plus second ratio first coordinate divided by sum of the ratios. Alright? This is equal to 15 minus 8, there is 7, so 7 by 5. Then minus 27 plus 14, that means minus 13 by 5. So this is the point which divides internally. Join of PQ internally. Number B, externally. So we will use the external division formula here. So what is the external division formula? First ratio, second coordinate. So 3 into 5 minus second ratio. This is x coordinate. So coordinate should be x coordinate. Second ratio, first coordinate. Divided by difference of the ratios. The ratios are 3 and 2. Difference of the ratios. For y coordinate, the same formula. First ratio, second coordinate. 3 into minus 9 minus second ratio first coordinate divided by difference of the ratios. So this is 15 plus 8, 23 by 1, that is 23, minus 27 minus 14. Minus 27 minus 14 is minus 41, and 3 by 2 is 1. So this is the point. Okay. Then here we have found the point. Sometimes the point will be given and we will be asked to find the ratio. Okay. Let us move to the second example. Find the ratio in which the line segment joining P5 minus 7, 5 minus 7 and Q minus 1 6, minus 1 6 is divided by the point R minus 719 minus 719. Okay, then it is asked, is the division internal or external? So first of all we have to find the ratio, then we have to say that whether the division is internal or external. So let's see how to solve such type of questions. First of all we will consider the ratio here. Let the ratio of division be m is to n. So we have considered the ratio as m is to n. Now we have to apply the formula, but we don't know which type of division is. Is it internal or external? No matter. Okay, we don't know what type of division it is, internal division or external division. So without knowing, we will apply it as internal division. We will use the internal division formula. After solving, if the ratio becomes positive, then the division is internal. We apply the internal division formula and solving, find the ratio. If the ratio comes out to be positive, then we will understand that the division was internal. But if the ratio becomes negative, on applying the internal division formula, we get the ratio is negative, it will mean that the division was external. Okay? So we will use the internal division formula. Here, m is m, n is n, x1 is 5, x2 is minus 1. Okay, therefore, first ratio, second coordinate, minus 1, plus second ratio, first coordinate, divided by sum of the ratios. So this is the x coordinate of the point of division, but in our question, the x coordinate of the point of division is given to be minus 7, so this must be equal to minus 7. Do you get it? mx2 plus nx1 divided by m plus n is the x coordinate of the dividing point. But here the dividing point is given to be minus 790. So this x coordinate must be equal to minus 7. Okay. This implies minus m plus 5n is equal to minus 7m minus 7. This implies minus m plus 7m, okay, is equal to minus 7n minus 5n. This implies 6m is equal to minus 12n. This implies m by n is equal to minus 12 by 6. This implies m is to n is equal to minus 2 is to 1. Okay. So we have applied the internal division formula and found the ratio to be negative. That means the division is external. Therefore, the ratio of division is 2 is to 1. And what type of division is this? External. So we will write 2 is to 1 external. Okay. So our next question is, find the ratio in which the line segment joining the points Find the ratio in which the line segment joining the points P 3 5 and Q minus 2 7 is divided by the x-axis, and hence find the coordinates of the point of intersection. Okay, first of all we have to find the ratio of division and then to find the point of intersection. Here neither the point of intersection nor the point of division is given. Okay. But it is given that the join of PQ is divided by x-axis. And we know a special characteristics of x-axis. Y-coordinate of every point on x-axis is 0. Okay? Y-coordinates of every point on x-axis is 0. Similarly, x-coordinates of every point on y-axis is 0. So, we know that whatever be the point, its y-coordinate is 0. We will use that characteristic to find the ratio. So, in this way we know the y-coordinate. And the previous problem we have shown that if only one coordinate, either x or y, is known, then the ratio can be found out. So here we know the y-coordinate. Let the ratio of division be m:n. Next, since y-coordinate is also known as ordinate and the x-coordinate is known as abscissa. X-coordinate is called abscissa, y-coordinate is called ordinate. You can write also ordinate here. Okay. Since y-coordinate of every point on x-axis is 0. Therefore, 0 is equal to, for y-coordinate we will use the internal division formula. So, first ratio, second coordinate plus second ratio, first coordinate 5 divided by sum of the ratios. This implies minus 7m plus 5n is equal to 0. This implies 5n is equal to 7. This implies 5 by 7 is equal to m by n. Therefore, m is to n is 5 is to 7. Therefore, the ratio of division is 5 is to 7. And what type of division is this? We have used the internal formula and we have got the ratio as positive, so the division is internal. 5 is to 7 internally. Now we have to find the point of division. One thing we know about the point of division, that the y-coordinate is 0. So we will take this as let x0 be the point of division. Now we know m is to n. Therefore, x equal to first ratio, second coordinate 2 plus second ratio, this is the second ratio, into first coordinate 3 divided by sum of the ratios 5 plus 7. This is equal to 10 plus 21, that is 31 by 12. Therefore, the point of division is 31 by 12, 0. X0 was taken as the point of division and the value of x is 31 by 12. So the point is 31 by 12, 0. Okay. Next. Next question is, the line segment joining P21 and Q minus 4 A is trisected at the point zero 7/5. Find the value of A. Value of A. Okay. So trisect, that means divided into 3 equal parts. Okay. We have to find value of A if the join of P21 and Q minus 4A is trisected at the point 0, 5, 7/5. Okay. So first of all, let us try to understand what is trisection. Suppose this is a line. If it is trisected, so these two will be the point of division. Okay. For this point, say P, Q and ABB the points. So for this point of division trisection A, the ratio will be 1:2. And for the point B, the point of division will be 2:1. So there are two ratios of trisection. One is 1:2 and the other is 2:1. We don't know which ratio is here. First of all, we have to find the ratio. We have to find either whether it is 2:1 or 1:2. Okay. For that, you see here, all the x coordinates are given 2, -4, 0. And in case of y coordinate, there is an unknown A. So we will use x coordinate to find the ratio. Okay. Solution. Let m:n be the ratio of trisection. Therefore, first ratio for m, we will apply for x coordinate to find the ratio of division. First ratio, second coordinate -4 plus second ratio first coordinate 2 divided by sum of the ratios is equal to 0. This implies -4m plus twice m is equal to 0, implies twice m is equal to 4m. This implies 2/4 is equal to m/n, implies m is to n is equal to 1:2. Now we know that the ratio of trisection is 1:2. That means this point will be the point of trisection. Now we can find the value of A. Therefore, A is equal to, now we know the ratio 1:2. First ratio is 1, second ratio is 2. So first ratio, sorry, not A, this is 7/5. I'm sorry, 7/5. So first ratio, second coordinate. What is the second y coordinate? A. Plus second ratio is 2. First coordinate 1. Two into 1 divided by sum of the ratios 1 plus 2. Okay. Let us check it. First ratio, second coordinate plus second ratio, first coordinate divided by sum of the ratios. This implies 7/5 is equal to A plus 2/3. This implies 21 is equal to 5A plus 2. This implies 5A is equal to 19. This implies A is equal to 19/5. Thus, now we know the value of A. So we have done up to this. Now we have just to remember two more points from the section formulae. Suppose P and Q are 2 points and their coordinates are given to be x1, y1 and x2, y2. So what is the midpoint? For midpoint, you see the ratio will be 1:1. Okay, as being the midpoint, both sides are equal, so the ratio will be 1:1. So the coordinates of the midpoint is first ratio second coordinate plus second ratio first coordinate. That means x2 plus x1, which can be written as x1 plus x2. By sum of the ratios, 1 plus 1, 2. Okay. So what is midpoint? Midpoint is the average of the coordinates. Then centroid. Which point is called centroid of a triangle? The point at which all the medians intersect is called the centroid of a triangle. Geometrically, the point at which all the medians intersect is called the centroid of a triangle. Now, what is the centroid of a triangle whose vertices are, say, x1, y1, x2, y2 and x3, y3. Centroid of a triangle whose vertices are x1, y1, x2, y2, x3, y3 is x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. So centroid is also average of the coordinates. Here there are 3 coordinates, so divided by 3. And in case of bisection, there are 2 coordinates, so by 2. Okay. So centroid and the midpoint are nothing but average of the coordinates. Just remember that, average of the coordinates. So by applying this formula, you can find the midpoint of the line segment joining 2 points, and by applying this formula, you can find the centroid of a triangle whose vertices are, if the vertices are given, x1, y1, x2, y2, x3, y3. Okay. Then there comes area of a triangle. The formula for finding area of a triangle. Suppose this is a triangle P x1 y1 Q x2 y2 R x3 y3. You can also write in this way: P x1 y1 Q x2 y2 R x3 y3. Okay. Suppose x1 y1 x2 y2 x3 y3 be the vertices of a triangle. Then what is the area? Area is given by delta is equal to plus minus half x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. So this is nothing but a cyclic orientation of 1, 2, 3. You see 1, 2, 3, 2, 3, 1, 3, 1, 2. Okay, a cyclic orientation of 1, 2, 3. 1, 2, 3. So 1, 2, 3. First one is 1, 2, 3. Second one is 2, 3, 1. Third one is 3, 1, 2. Okay. X is outside and y is inside the bracket. Okay, so 1, 2, 3. So 1 means it will be x, x1, y2 minus y3. Then 2, 3, 1 means x2 into y3 minus y1 plus 3, 1, 2. That means x3 into y1 minus y2. This gives the area of the triangle. Okay. So why this plus minus? The sign depends upon orientation. What is orientation? Orientation is the way in which you have arranged the points P, Q, R. You see, here I have written P, Q, R. Here I have written P, Q, R. So P, then Q, then R. It's moving anti-clockwise. This is called anti-clock orientation, and here the orientation is clock. P, Q, R. P, Q, R. Here the orientation is clockwise. Here the orientation is anti-clockwise. So if the orientation is anti-clock, then area will be positive. But if the orientation is clock, then the area will be negative. Okay. For clock orientation, area will come out as positive. For anti-clock orientation, area will come out as negative. But area is always a positive quantity. Okay. So suppose our area comes out to be minus 6. We will say that the area of the triangle is 6 square units. And we will understand that the orientation was clockwise. The orientation was clockwise. Okay. Am I doing right? Okay. This is the clockwise orientation. This is the clockwise orientation. Okay. And this is the anti-clockwise orientation. So this area will come out to be positive if we arrange the points P, Q, R in this way. This is anti-clock. And in that case, the area will come out to be positive. And if the orientation is clockwise, the area will come out to be negative. Okay, that's why positive, negative. But in the answer, we will always write it as positive. Okay. So let us solve one problem. First one is find the area of the triangle whose vertices are minus 2, 3, minus 3, 4 and 1, 2. 1, 2. Okay. What is the orientation? Next question is, what is the orientation? So this is the first point. So these are x1, y1. This is the second point. So these are x2, y2. This is the third point. So these are x3, y3. Solution. Delta is equal to half x1. What is x1? Minus 2 into, you can give plus minus, minus 2 into x1 into y2 minus y3. y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. Okay. This is equal, you can use modulus also here. Instead of plus minus, you can use modulus. So minus 2 into 2 is minus 4. Minus 3 into minus 1 is plus 3. Then 3 minus 4 is minus 1. Half. This is equal to plus minus half into minus 5 plus 3 is minus 2. You see, here the sign is minus, that means the orientation is negative. This is equal to 1 square unit. So the area is 1 square unit, but the orientation was found to be negative. This negative sign indicates that the orientation is clockwise. Therefore, the area is 1 square unit and the orientation from this sign, the sign that comes within the bracket will give us the orientation, and the orientation is clockwise. Okay. Now we'll discuss about collinearity. So suppose this is a triangle A, B, C. Now if the 3 points are collinear, if the point B goes to here, okay, then in that case, will you find any triangle here? Yes, still 3 points. Theoretically, we will find a triangle here. But what will be the area of the triangle? The height of the triangle will become 0. So its area will be 0. Do you get my point? To find the height, we will draw a perpendicular here. This will give the height. But if the point B goes on the line AC and the 3 points ABC becomes collinear. Collinear means lying on the same line. Collinear means lying on the same line. If the 3 points lie on the same line, in that case the height of the triangle will be 0. So the area will be 0. Thus, if 3 points ABC are collinear, then area of the triangle ABC is 0. Okay. We will solve a problem depending upon this. The 3 points. Okay. This is the question. Show that the points show that the points A0 to B37 and C612 are collinear. So we have to show that the 3 points ABC are collinear. That means we have to show that the area of the triangle ABC is 0. Solution. Here, area ABC is equal to plus minus half. So what is x1? x1 is 0 into y2 minus y3, 7 minus 12 plus x2. What is x2? 3 into y3, 12 minus y1, 2 plus x3. What is x3? 6 into y1 minus y2, 2 minus 7. This is equal to plus minus half, 0. So 30 minus 30. So this is equal to 0. Therefore, the points, the area is found to be 0. Therefore, the points are collinear. The points ABC are collinear. Okay. The area has come out to be 0. Therefore, the points ABC are collinear. Next question. If the points 1, 0, 0, 1 and alpha beta are collinear, prove that alpha plus beta is equal to 1. If the points, these 3 points are collinear, we are to show that alpha plus beta is equal to 1. So since the points are collinear, therefore the area of the triangle must be 0. Since the points are collinear, therefore delta is equal to 0. This implies plus minus half x1, that means 1, into y2 minus y3, 1 minus beta, plus x2, 0, into y3 minus y1, that means beta minus 0, plus x3, that means alpha, into x1, y2, y1 minus y2, 0 minus 1 is equal to 0. So this plus minus half will cancel out with 0, and there will remain 1 minus beta minus alpha is equal to 0. This implies 1 is equal to alpha plus beta. This implies alpha plus beta is equal to 1. And as proved. Next, area of a quadrilateral. How to find the area of a quadrilateral? Suppose this is a quadrilateral. So this is a quadrilateral whose vertices are A, x1, y1, B, x2, y2, C, x3, y3, and D, x4, y4. Okay. Then the formula for area of the quadrilateral is given by area of the quadrilateral is equal to plus minus half x1 y2 minus x2 y1 plus 1 2 then 2 3 x2 y3 minus x3 y2 plus 2 3 then 3 4 x3 y4 minus reverse x4 y3 plus 1 2 2 3 3 4 then 4 1 x4 y1 minus x1 y4. So how to remember? 1 2 2 3 3 4 4 1 1 2 2 3 3 4 4 1. Okay, first 1 2 then 2 3 then 3 4 then 4 1 x1 y2 minus x2 y1 1 2 then reverse. Okay, then 2 3 then reverse, 3 4 then reverse, then 4 1 reverse. Okay, I think you can remember this. Otherwise you can also find the area by dividing into two triangles, but while calculating the area you must consider the orientations of the two triangles should be same. If you say this triangle as ABC, then if the area of the quadrilateral ABCD will be ABC, area of triangle ABC plus area of triangle SCD. If instead of writing SCD you write with ABC, if you write ADC, then the answer will be wrong. If you take ABC anti-clock orientation, then you have to take SCD. Same orientation must be considered. If it is anti-clock, then that must also be taken as anti-clock. If it is clock, then that must also be taken as clock. Okay, the orientation of the two triangles should be same. Okay, so area of this triangle plus this triangle you can find in that way also, or else you can find by using this direct formula 1 2 2 3 3 4 4 1 1 2 2 3 3 4 4 1. 1 2 2 3 3 4 4 1. Okay, so I leave it to you. You will find the area of quadrilateral. In our next video we will discuss about locus, and this video and share just the homeworks. So these are your homeworks, class book, exercise 11, question number 2, 3, 7, 8, 9, 10, 11, 15, 16, 18, 19, 20, 22, 26. Okay, so you do all these homeworks. In case of any confusion, don't hesitate to discuss me. Okay, thank you.